guys, here in this video we'll see a problem on involute of a circle. For that, here is a question. One end of an inelastic string 125 mm long is attached to the circumference of a circular disc of 50 mm diameter. The free end of the string is wound around the disc, keeping the string always tight. Draw the locus of the free end and name the curve. So this is the question in front of us. Now here in this question, if we see, it is given that there is an elastic string which is wound around the disc and keeping the string always tight. So when an inelastic string is wound around the disc, keeping the string always tight, the curve which we get, it is called as an involute. So now I would be drawing an involute here, and for that I'll have to take the diameter as 50 mm. So I'll start with that. The diameter is 50, so radius is 25 mm. So keeping this center, radius is 25 mm. Here I'll draw this circle. Next, I would be dividing it. Dividing the circle into 12 equal parts so that we get more number of points to draw the curve. Measuring 30. So when the circle is divided into 12 equal parts, each angle would be of 30 degree. After I have divided it into 12 equal parts, here I'll give the notation. Next, when I calculate the circumference of the circle, the diameter is 50, so therefore circumference is pi d, which gives me the value as 157 mm. So next, I'll mark this circumference, that is 157 mm, over this horizontal line. Then, like I have divided this circle into 12 equal parts, similarly this line which represents the circumference will also be divided into 12 equal parts. For that, I am measuring an acute angle here of suppose 15 or 20 degree. It should be less than 45, so I am taking 20 degree here. Then I'll divide this line which is inclined into 12 equal parts by taking 1 centimeter distance in the compass. So divided this into 12 equal parts. Then connecting the last division up to the point where I was getting the circumference, which is 157 mm. Drawing parallel lines. Then in a similar manner, giving the notations here as well on this horizontal line. Now in this question, the length of the string which is given is of 125 mm. It means the length of the string is less than the circumference, which is 157 mm. So I'll mark the length of the string here, that is 125 mm. So this point represents the length of the string. And now when the involute will be drawn here, it should end at this location because the length of the string is less than the circumference. That is, when the string is wounded over this circle, it won't be completing a complete circle. It will end between 9 and 10. So this much part will remain. So for that, I'll measure the distance from point 9 up to point P, and it is between 9 and 10. So here I get point P on the circle. Now after this, I need to draw the tangents from each of the points. So starting with point number 1, so after drawing the tangent through point 1, next I'll measure the distance from point P to point 1, keeping it on point number 1, that is the tangent, and I'm marking over this tangent. So here I'm getting this point. Next, drawing the tangent through point 2, so like I have marked from P to 1, now I'll measure the distance from P to 2, cutting this tangent. Similarly, drawing the tangent through point 3, measuring from P to 3, keeping it on point 3. Next, measuring from point 4, measuring from P to 4, keeping it on point 4, marking on the tangent, then from point 5, measuring from point 5 up to P, keeping it on 5 and marking at the tangent. Then drawing the tangent through point 6, measuring from 6 to P, keeping it on point 6, marking over the tangent, drawing the tangent through point 7, measuring from P to 7, drawing tangent through point 8, measuring from 8 to P, then drawing tangent through point 9, measuring from 9 to P, keeping it on point 9, cutting the tangent. Now all these points needs to be connected in order so that we get the involute. Here I'll give the notation that this is point 1 dash, 2, 3, 4, 5, 6, 7, 8 and 9. Joining these points in the proper sequence with the help of a French curve. Next, I'll join all these points and make them dark. First, I have drawn it light. Next, I'll make this circle dark. In the question, it was given that draw the locus of the free end and name the curve. So this is the locus, and here I'll say that therefore the curve is an involute. And next, here we can even draw tangent and normal, since it is here in the question it is not given that we have to draw the tangent, but if it would have been given, then how to draw that? For that, here we are already having tangents to this base circle, so we can take any one of the tangent here like this, or if we want, then we can select any other point onto the circle as well, like I'm selecting a point here, and then drawing a light line through that point. Next, this point will become my reference, so taking it as the reference here, drawing a tangent. Now this is a tangent to the circle as we see here. Next, after drawing this, Here I'll draw a tangent to this curve passing only through one single point, and then I'll make these lines dark. So here T dash, I'll say that is the tangent, and N dash, that is the normal. So that is tangent and normal to this involute. So this is the way we have to show the tangent and the normal. Next, here I'll give the dimensions to the circle. Diameter is 50 mm. So this is the circumference, pi d equal to 157 mm, and here is the length of the string. At last, drawing the center lines through the circle, and with this the problem gets completed.